Hello guys, and welcome to the very first lesson in our free course, Freedom from Fractions. This is lesson 1. It is a brief introduction to what a fraction is. So let's just jump right in. So guys, we understand how to count whole numbers 1, 2, 3, 4, 5, and on. But sometimes when we are measuring things or just in different situations in life, we might find a number that's between one of those whole numbers. That's where fractions come into place. They represent parts of a whole. So say, for example, we have a pizza. There's our pizza. And we want to share pizza with some friends. Let's say for this example, we want to share our pizza with 4 friends. So first we might want to split it this way. And then we might want to split it this way. Now I tried my very best to split this into 4 equal pieces because if we're sharing the pizza with friends, our friends definitely want to make sure nobody gets more than the other. So fractions are when we take a whole and we split it into equal parts. So a fraction is simply a way to represent parts of a whole. Now we know fractions are generally represented with a number on top, and then a bar, and then a number on the bottom. So this symbol is representing number, not hashtag. Okay, or pound. So the number on top we call a numerator, and the number on the bottom is called a denominator. The denominator is how many equal parts the whole was split into. The denominator is how many equal parts the whole was split into. So for our pizza example, our denominator would be 4 because we have 4 equal parts. And our numerator is how many parts we're going to talk about. So in this case, each friend is going to get 1 piece. So our numerator would be 1. Let's look at a few examples. So we're going to talk about this section of describing equal parts as a whole. Number 1, Zach and Tia had the same size gardens. Which garden has more room to grow beans? Explain. So if we look at our picture here, we have Tia's garden that's shaped like a square and Zach's garden that is also shaped like a square, and they are the exact same size. Tia splits her garden diagonally into 2 equal pieces, 2 halves. Zach also splits his garden into 2 equal pieces, 2 equal halves. So in this case, they both have the same amount of room for their beans because their gardens are the same size and the beans are both a half. So the answer to this question would be neither. Neither garden has more room to grow beans. This is because both gardens are the same size and the section for beans is 1/2. Let's look at number 2. We are to decide whether the shape is divided into equal parts or unequal parts, because we know if we are going to write a correct fraction, we have to be discussing equal parts. Let's look at number 2. I can count that there are 3 parts. There's 1, 2, 3. However, these 2 pieces look alike, but this one does not. So these are unequal parts. Number 3. Are the parts equal or unequal? Well, let's count and see how many we have. 1, 2, 3, 4, 5, 6. 6 triangles that all look identical. So this would be equal parts. And lastly, number 4, we have 1, 2, 3, 4 parts. This looks like our pizza example, and these parts are equal. Let's do a few more. Question 5 says, Alex says he divided both of these casserole pans into eighths. Does this statement make sense? Explain. So let's look at pan A and pan B. Pan A, we can see has 1, 2, 3, 4, 5, 6, 7, 8. So yes, there are 8 parts. Pan B has 1, 2, 3, 4, 5, 6, 7, 8 as well. However, if we think back to the questions we just answered, Pan A has equal parts, Pan B has unequal parts. So which one would really be eighths? Remember that parts have to be equal in order for us to say that we have divided it into eighths or halves or any amount of parts. So in this case, Alex's statement does not make sense. And the reason why is because pan B is divided into unequal parts. Moving on to number 6, write the name for the equal parts. So this is simply asking how many parts has it been divided into equally or split into equally. And so we will count it, and that's how we'll come up with our name. So question 6, we have 1, 2, 3 is split into 3 equal parts. We call that thirds. Question 7, how many parts do we have here? Or how many equal parts? 1, 2, 3, 4, 5, 6 equal parts. So this would be 6. THS on the end, 6. For question 8, we have 1, 2 parts, but we don't use a name with the name 2 in it. We wouldn't say twos or twos. We say halves. Halves is when we split it into 2 equal parts. Question 9. The steps of a water cycle are precipitation, evaporation, and condensation. Mia divides a poster into thirds to show these steps. Label the rectangle and draw lines to show how Mia could divide her poster. So we can see from the problem that we need to divide her poster into thirds. Thirds means we need 3 equal parts. 3 equal parts. So I'm going to do my best to draw some lines to split this poster into 3 equal parts as best as I can. Now, my divisions might not be perfect, but you understand that we are trying to make those 3 sections equal. Okay, it almost looks like a science fair board now. And we would label her poster for the 3 parts of the water cycle that Mia is studying. So we're going to put a P for precipitation, E for evaporation, and C for condensation. And that would be Mia's board. Let's make sure we really understand with some test prep problems to sum it all up. Question 10. Carmen folds a sheet of paper into halves. Select all the statements that are true. So if Carmen folds the sheet of paper into halves, we know that halves is 2 equal parts. Let's go through each answer choice and decide if it is true or not. A, the paper has equal parts. Well, we know if it's split into halves, then that's 2 equal parts. And so A is definitely correct. B, the paper is divided into 2 parts. Yes, that's true because there are 2 equal parts. That would be 2 parts. C, each part of the paper is the same size. Well, that's similar to A. Same size means equal. So yes, the 2 parts are the same size. D, all halves of all sizes of paper are the same size. That sounds like they're saying if I take a sticky note and fold it in half, that its half would be the same size as if I took a postcard and folded it in half. That's not true. All halves are not the same size for all sizes of paper. E, a paper folded into thirds has fewer equal parts than Carmen's paper has. Well, Carmen split hers into 2 pieces. If we were to fold a piece of paper into thirds, it would be 3 pieces. And 3 is not fewer than 2. So E cannot be correct. Let's look at 11. Shonda draws a flag. She divides it into fourths. Which could be Shonda's flag? Let's go through each answer choice and see. A has 1, 2, 3, 4, 5 equal parts. But 5 equal parts we would call fifths. So A is not the answer. B does not have equal parts. Those parts are unequal. So it can't be Shonda's flag. C has 1, 2, 3, 4 parts, but they are also unequal, so C cannot be Shonda's flag. D has 1, 2, 3, 4 equal parts, so this could be Shonda's flag. Our last question, question 12, which shape shows eighths? Which shape shows eighths? A has 1, 2 equal parts, that's halves, that doesn't work. B shows 1, 2, 3 equal parts, that's thirds. C has 1, 2, 3, 4, 5, 6, 7, 8 equal parts, so C is the answer. But let's just make sure we know why D isn't. 1, 2, 3, 4, 5, 6 is 6, that's not eighths. So this has been our lesson 1, Introduction to Fractions, knowing that fractions represent parts of a whole, and now we've gone through how to describe equal parts of a whole. See you in the next lesson.